Okay, we are doing horizontal shifts left and right and vertical shifts up and down of the exponential function. And so I have the equation written for an exponential function. I used a base of 2. Realize that this base can change. It can be 1/2, it can be 1/3, it can be 3, it can be 4, it can be 5, it can be 2/5, it can be 3/4. You get the idea. You have infinitely many bases. However, all this is pretty much similar to the quadratic function that you used back when we were doing quadratics. If it's here and up in the air, sometimes there are parentheses here, and that's your horizontal movement. That's like with the quadratic function, it had to be inside the parentheses, and they sometimes put parentheses there. And so there aren't any now. But just realize if it's up high, if it's in the exponent and up off the ground, then it's a horizontal shift, and this is our vertical shift. And just the same as it was with quadratics, a plus does not go right like our mind wants it to do. A plus shifts left and a minus goes right. And with the K, that's our vertical movement, and it's over here, and it's a plus or minus sign. And but it's down on the ground. I tell my students it's level with the rest of the equation, and that is vertical movement up and down, and it does exactly what our mind thinks it ought to do. A plus goes up and a minus goes down. So here's our first example, just using the parent graph of f of x equals 2 to the x, and you see it graphed in pink here. And then I've got plus 1 up in the exponent. That's a horizontal shift left of 1. And I just find myself some corners on the graph and move it left 1. Just find yourself a corner, one that's going through an actual point that you can see. They're all points, but one, and shift it left. And there we are, there's the new graph. And we call this, when we compare, we call it, I abbreviate, a horizontal shift left 1. This one's going to be a horizontal shift to the right of 3. And again, you take a corner and you move it right. And I just moved it right 3 and made my new graph. And this is a vertical shift up of 3. And I wrote here it has an asymptote of y equals 3. This number on the end is going to be the line, the dashed line, or the part that you're going to approach but never cross. Exponential functions have a place that they approach but never cross, and that's going to be that part there. But this is shifting it up 3. You just find points on the graph again, shift them up 3 points, just find yourself a corner, count up 3, and make your new graph. This one has both. I am horizontally shifting to the right 1 and vertically shifting up 3. So I found myself a point, I went right 1 and up 3. I found another point right here, right 1 and up 3. And then I did this one here, I did that one already, and this one, right 1, up 3, there would be this one. And then this one here, right 1, up 3, right there. And make yourself your new graph. All right, what do we do when they're just showing you the graph and asking you to identify the transformation? Well, this is up here in the exponent. It's a minus sign, so it's going right. This is a horizontal shift to the right of 5. This one's down. It's not part of the exponent, so it's a vertical shift down, and I wrote 2. It's a vertical shift down of 5. Sorry, I have la-la-ville moments where when I'm teaching it, after writing it all out, I see my mistakes. All right, this is a horizontal movement. It's horizontal to the left 1 and vertical shift up 3. And now this one, here's the function that you're translating, y equals 2 to the x power, and you want to move that 2 units right. So all I did was show this, since it's right, it's up in the exponent, and that would be a minus 2. So 2 to the x minus 2. Vertical up 3. So I write my 2 to the x, and I don't put it in the exponent. I put it down here level and write plus 3. And then to do both of them, this one's 2 units left and 4 units down. Remember, left is plus and minus is down. So, and that is it.